Our next part is a sub-assembly part, which is a gear cover. It's a welded assembly and it has two parts. We have a side plate, which you see on the screen, and we have an attached rolled sheet metal plate with the same thickness properties of the side plate. Let's start modeling of our gear cover weld assembly. For the side plate, which is at the back side of our part, I'm going to use the general sketch in order to get these details from the first body part. For this reason, I will just open my winch assembly, the body part, first of all. Double click and save this file as a gear cover plate. I hit this one and save my file save as my file. This time I will use, it is my fourth part, but I will just create a new part file, which is gear cover plate. This is the fourth part. It will be our fourth assembly, and it will be a gear cover plate. I have saved this one. Then I will just delete the features which I have. The flat button, because it's also a flat, I will just delete. And this time I also delete. The only thing that I need is this flash detail, which I have created with this extrusion. I need this detail, this sketch only. This sketch. I'm going to use this detail in my part. For this, I'm not going to just create the other details. For this, I will just delete, but I do not delete the sketches which I have created onto it. And the only thing that I need is this sketch, and I will just recover this sketch. I just delete, and I delete and leave the sketch on here. The next thing what I'm going to do is I will just clean and delete the details which was previously I have taken from the part body part. I'll just go delete. Also delete this detail. Just check my part here. I have left one sketch. The thing that I need is here. I will just make this point coincident at origin point. I'm sorry. Take it back. My move. I will just move all the details. Move command. As a base point, I will just make this one all the constraints removed, yes, and move this point as a group to origin point, which I have seen here. Let's make this point on it, or you can just leave as it is. And please be sure that you are going to lock the details without. I need this point. Or if you want, you can just create a 6-point the details of our part. Anyway, what I'm going to do is I will just create that details by hand, which is this one, and I have this detail, which is I will just make this line coincident on origin point, and I need a dimension constraint, which is this one, and it is again, it is this line is on this point. Also, we have a dimension here, which is 6, as you see, and we have a detail from this point, which is a tangent line, which is this one, also another tangent line. Also, we have lost some dimensional relationships, which is this one and which is this one. So I need to just create two things here. It is not important, but I'll just consider this one. Also, when I have deleted this dimension, I have to create it again. Okay, I'm not interested in these details. The only thing that I need is this part. Finish my sketch. This time I will just create a side plate with these dimensions. For this, I will just double click, create a new sketch, which is this one. This time our part has a bigger dimension, which you see at this point. From this point we have 3.4 with the sheet material thickness, which is 0.06, and I will just make this circle shape by using this dimension. I will just get this point. For this, I will add a radius relationship, which is 3.4, which covers this dimension. Okay, let's use it again, no problem, for that dimension. The next thing, what I'm going to do is I will use this section to add my side plate. I have this one, created an extrusion tool. As you see, we have a sheet metal property, so if you want, you can just get rid of this sheet metal properties, convert to a standard part, then we turn a normal extrusion side plate. And this is the side plate. We have a thickness of 0.6 inches, 0.6 inches. This is our part. You can, it's up to you, you can use any side of this extrusion height. Let's use this side. Now we have this side plate on the back side. Also, we have some details added to it because we have an inside feature here. I'm going to add those to my sketch. Again, I will just start a new sketch. I'm not going to use this one, but I will use this plate to be extruded. So again, a radius here. I'm going to make this part radius, this one. Let me take my mouse back to show you better. I'm going to make this point, this arc piece. For this arc piece, I have the dimension from this line, which is 1 inches, and this axis, which is 0.5 inches, and our radius is 0.7 6. Let's have the first dimension relationship, which is the radius 0.76. Okay, the dimension is far from 1 inch here and 0.5 inch. And I will just connect 2 lines to this curve, this circle. And I need 2 lines for this. First, I get the tangent constraint to this curve, also another tangent curve to this hole, this circle. I will cut, trim for unnecessary parts. Then I will use again trim for the other pieces, but I would like to just create first coincident constraint. I would like to have this line and on this curve, and also this line and on this line. We have created this line here. Also, we are going to add, okay, before this one, I'm going to add a curvature here, which is 0.2. For that, I will just create a curve, a circle, having the radius 0.2 and make tangent to this one, make tangent to this one. Also, I would like to have this point on this line in order to have the curvature, and I would like to also have make a tangential constraint. I would like to move this line and make tangent to this curve. Let's trim the unnecessary parts. This will be my side plate. Okay, the next thing, I will do the same thing for other side. I would like to just make first coincident on this line and make tangent to this curve and make equal with this and this curve. Then I will just trim the unnecessary parts, which is this one. Also, yes, I think, okay, so right, and make this point on this line. Okay. The next thing, I will just create a tangential relationship about this line on this curve and make 10 trims for unnecessary parts, this one and this one. Now we have the cover plate here, and I will add this cover plate, the necessary portion, which is this one. I have all taken this portion here. I made a mistake. The bottom side is not equal to the top side. This one, I just choose the item, then choose the constraint with delete. I'm sorry, I would like to only delete the constraint like this. First select, then select the relationship, then the right click and hit the delete. And make this one, which is 0.26. Okay, finish my sketch and turn back to. I have the fillets on ends, okay. Let's have this tool again because I have made this one empty. Okay, we have the side plate. This is our cover plate with one fourth with the wand part. From this point, I would like to have a crate which saves us another part, which is the second part, gear cover plate roll. And I will use the outside diameter of this one. For this, I am going to use the same sketch, which is this one, and I will only get this outer surface. I will just delete this one. Let's have this one, accept, delete. Okay. The next thing, okay, I again delete, but I will leave this part here. First of all, I need to use only the outside of plate, which starts this point and this point. Before this one, I will just convert my part to sheet metal properties. And the thickness of our part is 0.06. I will adjust that thickness 0.06, which is this one, with OK. This time I need a sketch starting from this point. Again, I start a new sketch on this plane, but this time I will do a change about this outline. Start a sketch and edit the first sketch. I will delete, this is the empty. I will just split my arc shape at these points. As you see, we have one connection trim to and one connection trim to. I only need this geometry to be drawn. For this, I will just split and create a new sketch and get that geometry only. This one, I need this geometry I need. Finish my sketch and I will show you what I have just made. This one, I need this arc shape. It is just covered around this figure. Okay. The next thing, I need a contour flange tool. As you see, when I have one figure here, I have this one, this arc shape to be figured. I can change the offset direction to inside or outside from here, or you can just use the both side symmetry. As you see, we do not define any thickness at this point because we have already defined that thickness in sheet metal defaults. From this point, I will just take inside to weld that assembly into it or outside of it. It's up to us. And make this one with the thickness which I have seen from the top side. I will change my direction to outside of it to use the common planes, and I will have this geometry which is this length here, and I will just calculate 0.10 inches, and from this point 0.10 we have a plate thickness here. Also we can use this one, which is 0.38 here, and after that 38 we have 0.315. When I add all, I have this thickness which just fits to my needs, which is this distance which I have shown you on the paint. For this I need two formulas. From the back side here I need 0.38 0.38 plus 0.315. This is our part, ring part, which will be welded on our gear cover plate. For this one, I have to define a flat pattern here. When you just open, we have a flat pattern to develop length of our part here. For manufacturing processes, we need to have this part to be developed and save my part file. The next thing, what I'm going to do is I will make the assembly of these two parts. I have open, I get the place command, I have the winch here, I will need with control button pressed, I bring two parts. This is the normal assembly procedure. I escaped. The thing, what I'm going to do is, I will just fix the part first with grounded. Then I will add the figure shape. Before this one, I will just go back to my roll sheet and open the sketch visibility and save in order to use some dimension relationship in the assembly environment. The next thing, I will just use the made commands in order to have this shape. The first thing, I will just make the constraint. As you see, we have some details which we can use in our parts under the part origin folders. For example, I can use some details. If I do not have any details, I can just make this one constraint, this axis with a point something here, which I can use this axis also. I will just insert two things to each other. As you see, we have a rotation at this point, and we use the points which we have in our sketch. The next thing, I will just make the face mate. I will use this face and the back face of our part. I will change my visual style, but shade it with edges. The first thing, I need this one. The second thing, I need this one. As you see, we have almost fixed. I will just close my sketch visibility to work better on. As you see, we have the side plate, but the other plate, which is this one, the roll plate, it is just turning. For this, I need to add a mate constraint. With this face, you can use a point here or this shape. As you see, we have the constraint here. We have a cover constraint, which is this one. Okay. We have this detail. Okay, I add gear cover. It will be an assembly. I will change my figure. I will close the visibilities and parts. As you see, we have the gear cover, which will be mounted something like this on our plate. For other parts, we can just create this gear cover, technical drawing. Again, this time we use the gear because it has already opened the welded assembly here. Or if you want, you can just recall that welded assembly drawing. For this one, I need actually this plate. I can just change the scale to 1 to 2. Let's have this details. I'll arrange. And this time, what I need is, I need a part list for my figure here. This is my part list. I have opened a part list here. This is the part list. I will change this part list with some details. I need to get rid of this description. I remove and add some material, mass detail and the material detail. We will add these details. I will just move this down till to the other side. This is the mass in details. Also, I would like to have change the quantity after the part number, move down to it like this. Again, I enlarge like this. The next thing what I do is I will just double click on the sketch which is attached to my part view, and I will just create a little bit bigger because I need two other drawing here, a little bit bigger for other parts. Finish my sketch. I arrange this number, this part list to somewhere to this point. Yes. And before this one, I will just copy and paste for the part 4. This is gear cover. Weld assembly. This is our part description. Okay. The next thing, I need the base views. We have two parts actually. One gear cover plate, which is this one. I have created this view. I will change my view here, and I need a half scale of it from this point. You can just give your dimensions as you wish, because it's a simple, actually, a dimensional relationship. We have an axis line. We can just give the dimensions. You can also retrieve the dimensions if you want, but this is a very easy plate. We haven't drawn before, but this time we have this distance relationships. So I need these dimensions, which is this one, and this one. I need these dimensions to be specified. This is the dimension. Also I need the end radiuses. Okay, this is the dimension. For reference point, I need another dimension, which is this one. I'm sorry, I need an angular dimension, which is this one. From this point I can just try to design my parts with the given details. This is the part. I need a projection view, and I need the thickness of this part. As you see, I need only this dimension. Also, I need this dimension. What are the other dimensions? I do not need anymore. Yes, these are the dimensions which we would like to have. Again, I edit this figure and I will give information about this one. Finish my sketch. The part list, balloon here. The second thing, this is this one. And I copy the gear cover plate with paste. Gear cover, which is the number 1 gear cover plate. I will delete these details from the first figure. This is the gear cover plate 421 and gear cover roll, the second one. Again, I need the detail from the place view. I need the base view, which is this one, and this I need the gear cover roll. For this, it's a simple part, and I need the flat pattern of this one, because I will just roll over in it and I will just make the welt to each other. For this, I will just make this one flat pattern. I need only one view. With this one, I will delete the second line. Yes. And I have a band axis at this point, as you see. I have given the radius, which is 3.34 inches to the down or upside. It doesn't matter. It's a symmetrical part. We need the total length. This is our detail. Let me move to inside of our picture. We can just move this detail like this. And I need the thickness of this width. Here I have 2 lines. Again, I will just create a border line for my figure. This is my part border. I will just make this one a little bit higher here to interfere the part list here. For this one, I'm going to make a new text copy operation here, which is 4.2 with gear plate roll. I have just saved every part details which we have changed here. Okay, the next thing I need, it's a welded assembly. I need this one, welding symbols, and from this one I have forgotten, or I can just create a bigger one, circle, center line. Also, I can have the hidden lines to be seen here. For this, we have a welding symbol attached to this point, and it is a nut. It's a butt field, and the top of this butt field we have a straightness. After we weld, we have a straight connection. We have a butt field, around this one. Also, we can just create a rounded, this is not rounded, I can, yeah, a full butt weld, which will be like this. I will just add a weld bead here. We can weld it and then make this one. This is not a very complex part. And from this we can add some details from the weldments. We can just convert it to weld. This is the steel part, normal steels, and I need a weld bead, which is this part and this part between. I can add the symbol. This is a cosmetic weld. I'm going to make a loop, and I need a symbolic weld with creating the heel here. Symbolic weld. I will just take this one. As you see, we have a weld bead which just shows a cosmetic weld. Edit. Let me have an edge. I'm sorry. This one, I need this weld bead, and turn back to it and save it. You can also have some the other details to it, but for me, I'm not going to weld bead modeling at this point. We'll have some examples later, and I will just add the details of these by having the updating tools. Yes, I just save. You can also bring the weld details if you want to have. This one. Okay. We will continue with the other parts.
Our next part is a drum weld assembly. We have 4 parts. The first one is the gear part, which we have modeled before in the first videos. The second part is the bush part, which is welded to side plates with 2 different properties, which is the side plate with a hole, side plate without a hole. We weld all these parts into each other as you see on the top view. Let's make these parts.
We start our part creation with the first new with standard millimetric inch IPT. With double click, I have started a new part. We have already done this gear part in our first videos. We will just continue with the bush part creation. I have opened the visibility of the origin point and XY plane visibilities. For the length here, our drum length at this point, we have a stock on the between the wall sides here, which are 0.04 inches, and the dimensions that have the green color. The dimensions of this our bush is here, which is 1 inch from the outside and 0.5 inch in the inside. I will just create a normal do not shape, which have 2 profiles with the dimensions. The inside is 0.5. The biggest one is 1 inches. Finish my sketch. I would like to keep the midpoint and the plane or XY plane for in any case to use in the assembly environment. For this reason, I will just use a symmetric extrusion property, and this time I'm going to use, we have inside wall dimensions which is 4.2, and added to this point also we have a distance here, I'm sorry, we have a distance which is 0.2 from the side plate here. This is 0.2, it was overridden. And from this point I will just add these two values to each other to make the extrusion of our part. And this will be our third part, and this will be under our fifth assembly here. I will just save the part file with 5-2 push. Save the name as. I will assign the materials during our assembly model. I will continue the next part, which are these side plates. And the side plate here I have with a hole, and side plate here which I have without a hole. The first thing, I'm going to save a new part with -3, 5-3, and with the name of side plate with hole, and open the center point visibility and XY plane visibility. Start a new sketch to define our part. I will just make my mouse back. As you see, we have a dimension here which is 6.6 inches, and the plate thickness of this plate is 0.12. For this I will use the two things here. The first thing, we have 6.2. I will define that thickness. Also, the hole dimensions, you can get those dimensions from the top view, and the holes here are 0.375 with the two dimensions. As you see, we have two different sizes. For this, I will just create two lines to get these centers and give them the dimensions which I have seen on the front view, which is 1.6. I'm not going to use in the modeling for this. I will just turn them to construction. The next thing I will do, two circles, and make them by using equal constraint. This one and this one is equal, and one here we have 0.375 inches. This is our plate with the whole dimensions. Finish my sketch. Have the extrude tool, select the face here. This time again I'm just going to use a symmetric condition to keep the XY plane for mounting purposes at the mid of our plane. I can use also the faces for our mounting cases, but in any case it's a habit for my site. I will just make the extrusion length, which is, as you see, 0.12. Like this. This is the plate with hole. I will again save as my part file without a hole. And this time I will remove in without hole file, I will remove the dimensions and some details around this, as you see. Okay, let's make the drum assembly. I have opened a new assembly file and bring my parts from the plates command. This time I'm going to use the gear set. In the first video we have just created the first gear set, which is this one. I'm opening this assembly, gear assembly. I'm sorry. Let me open first. By normal open, not a gear set. As you see, we have a gear set. It is not fixed. I'm not interested in this way. We have a gear set, but I need the gears here. The gears are stored under this design gear set folder, design accelerator. We have renamed those files, which is the gear in this section. I will just open this one, and only for this purpose I will again save a file, save as this file to the Winch folder here. What I'm going to do is I will just change its name to 521 gear to use in our assembly. I'm going to use this model in our assembly. Okay, I will close. I will not save, and place the files, which is this one. I will just select all the parts in this drum assembly. Okay, we have the gear here with these properties. Anyway, for gear set, I will just change and rename this. As you see, we have a part, and this is our key point here. The part number will be, or the part description will be like this. We can also use the numbers instead of the part names. Again, what I'm going to do is I will just firstly place, I forgot something in our part side plates. This side plate have a hole for mounting purposes because it is just passing through. Let me show you. It just passes through this side plate. I have forgotten that one. Okay, I will just go with right click, open, to edit, start a new sketch, or I will just go to the first sketch. Then I will just open a hole in our plate with 1 inch thickness, 1 inch diameter. I will change the first, double click, change the profile here. I'm interested in this profile. Do the same thing for the side plate without a hole. This is the side plate without a hole. With hole, I'm just going to open, edit the sketch with double click, create a new circle, and give its dimension as 1 inches. With double click, I will just erase the profile, and I need this shape to be extruded for my figure. Save this file and go back to assembly. In the assembly files, in Inventor 2020 or 21, I'm not sure about this one. I use the 22 version. I use the shaded edges with the view menu visual style with shaded with edges in order to grab the edge relationships. The next thing, I save my part file the assembly file, which is part 5 drum weld assembly. This is the part files. I have just, as you see, we have a tab with the lighting, an icon with the lightning. I have just, this means that it is an update, local update of our parts, which we have changed it. The next thing, I will just fix my spur gear with right click or this side, or we can use this window here. I have this one to be grounded first. We will just mount our plates on this gear. Here what I'm going to do is I will use the center points for axis constraint. For this I'm going to use the joint command. It's not a very important part. We will use in the mechanisms this joint. I'm not going to use the constraint. For this I need the back side of the part with the hole. This point I need. As you see, I will just go, and this point to be fixed on my gear surface, which is this point. As you see, we have fixed around. Okay, we can just define that relationship. It's not very important at this point. We will just fix that with a constraint command. The next thing, what I'm going to do is again joint. This time I will use this point, which I have seen. I'll show you here. It grabs this point. I will just make coincident, which is this point, to each other, as you see. Okay. You see, we have fixed this one, and this time in animation of the joint movie we have that point which is sticked to this point because it is fixed and this is fixed to that one, and we have just moved this bush part to our assembly. The next thing what I'm going to do is I will just make again a joint command. It is same as mate. We just use two mates this time. We use this point and this surface as this point coincident on this point. I'm using this point first. This is the point that I'm going to use. Also this point to just fix. The animation, please do ignore this one first of all. Ignore this animation and finish your sketch. The next thing, what we are going to do is, for example, we will just use a sectional cut, which we have seen in this drawing. For this, I would like to have these holes straightened to our part. For this reason, I will just use this side plate with a whole origin plates. These are the planes that I'm interested in. I will open the sketch visibility, and I would like to have that plane to be seen directly on any other plane which I can see in my figure. Here I would like to just create a relationship, an angular relationship. I will just define an angular relationship. As you see, we have the relationship folder here. We have the joints here, and I would like to make a constraint. This time I use two quantities for these two planes. I would like to be in the same level. For this I use an angle constraint with two solutions and make this plane, which is under the parts side plate with a hole, exact plane, to be in the same direction, which is side plate the assembly XZ plane on the same direction. You can also just define an angular constraint if you want so, but for example 180 or 90 degrees if you want to, which is perpendicular to each other, or you can just leave as it is with 0 degrees, which are on the same surface directions. This is our side plate, the drum welded assembly. I will just close the visibilities of our plane. Also for this one, this is the drum weld assembly. You can use X with the right click. You can just collapse all the parts with one click. I'm going to save my assembly first. Then I will just make the dimensions. Also, I will use XY plane and close this visibility. As you see, we have a fault at this point. Also, I think I have another fault at this point because it just passes through here. It just passes through, and it will be the dimension here, which is 0.10 far from this one. It is 0.6 here, the distance between these two circles. I will just delete this rotational joints, also this one. I have no limits reserved here. We have, I will just take my mouse back as much as I can. Fast, I would like to be fast. Which is, this time we have 10 inches and 0.04 inches here, which is this dimension here I have highlighted is 0.06. I will just again make the gap here, constraint, not constraint, to joint here, this surface and this surface to be gap with 0.06. As you see, we have this time up, edit 0.06 to the other side. Let's animate this one, change this, I'm sorry, this time. This one, edit to the other side. I will again choose this point, again delete this dimension. Okay, I would like to have joined this surface point and this surface point. It will be coincident with a gap 0.06. Let's give 1 inch, whatever, yes, edit. Also I need to consider 0.06 with the plate thickness to the other side. I will change this direction, which is minus 0.06, change the direction, like this, yes. Also do the same thing for other side. I think the same dimension. Here we have 0.05, also this is 0.06, and I will just define that relationship, this pushing part. I will just constrain this surface to be in the same, not constraint, joint, I'm sorry, this surface to somewhere around this surface, with a gap, not this one, I'm sorry. Let's give this surface to be far from this one, as you see, with a gap. Let's calculate this one. We have 0.06 here, and also we have 0.315. I will add them all together. 0.06 plus 0.315, and I would like to have on the other side dimensions. Up, edit. Let's take the move back. This is the dimension. Again, use this point and this point, not this one. This joint and this joint, not rotational. I would like to have the same side, which is 0. Let's give 1 inch what it does. Edit. I will change this direction. Yes. I will adjust the gap here, not 1 inch, 0.0315 plus 0.06, and it is the minus sign. Minus with this. Yes. Again, I save the part files. Please check your connections if they are rotating. Let's have the technical drawing of this part. I will just open the gear cover. Well, this is our weld assembly. Also, we can just use the weld design for our parts from the environment. We can just convert it to welding, but I'm not interested in, so we can just use the tools which we have in the technical drawing. I will just close this one, save the part file. From this point I will place a base view for my drum. I can just use the top side view. I will make the cut and balloon it. From this point I'm interested in this view. As you see, if you want, you can have a projected view like this. We have created the first axis tool, these two axes. It is important, the dimensions are important. I just create a sketch for this view for breakout section. I will just cover all the part here, and I will just create a breakout view. Select this view and the depth. I can also use the hole here, all the depth to a point which is center of this one. I will create an annotation from these two sides, the center line of our parts. Also, we have some details about this. For our part, it's not very important this time. The whole directions, you can just define and bring the dimensions if you want. So in our case, our welding dimensions are important. Before this one, I will create a part list by selecting the parts here. Again, I create a part list below this one. With double click, I will just go enter and change the columns. I'm not interested in the description, but I'm interested in the material and the mass properties of it, and I would like to move the quantity to the downside. I will have disorder item, part number, quantity, material, and mass. With apply tool, I will get this, and I adjust my part list in one line. I will use the ballooning I need this time. I can use this way. I will double click for my part, drawing, use this line for creation, like this. Okay. The next thing, I will use the balloons. You can use also the auto balloon, but we have now 4 parts. First, this part. Okay. I have forgotten the mouse properties here. I'm sorry for this. I will just go balloon, right click with continue. This is the part list in our welded assembly. I'll just move this out again. This is our 4th part. This is our 3rd part in the assembly environment, and we can just arrange by having a line stick line grab, which is a vertical one. You can just define the dimensions, and this is a circular dimension here we have. Okay, the dimension I create, and I will change its property by adding the diameter symbol on it. We have this one. We give the dimensions of our part. This is our part thickness. I will change these dimensions in your submissions. Also this thickness I need, like this. I will arrange the main dimensions. For our part dimension we have from end to end. Also we have, if we can just grab the dimensions. In assembly we have to just give our dimensions one by one. Or you can just give the dimensions you have seen. The dimensions, we have manually dimension. This example, I'm not going to give the dimension because it's a very simple part. We will give the shear dimensions with a shear table for our case. The next thing, which is this one. Okay, I will give the hole here, which is 0.5 inches, and I will just define the dimensional relationships which we have calculated. I will just define for welding distances. I'm going to define this one to this one. So here. Okay. The next thing, yes, we have this dimension. The plate radius. Double click. I add with home tool. I will just go to this side and add this method. The next thing, I will just add the welding symbols. I need a weld at this point to connect the two parts. Here I'm going to use not a butt weld, I will use a fillet weld, and it's around this here. I need this one. Also, I need two welding. I'm sorry, I will need this point again with the full round properties. I have forgotten that one. I'll change this one with full round properties, and for my top view I need one welding point here, which is this one. It is welded. This weld connects these two parts, and I will just change and add a leader to this point to my figure. Okay, I have two welds. This weld, this leg connects the part 2 and part 4 to each other. This weld, this leg, which you see here, connects the part 1 and part 4 into each other, and this weld connects the part 2 and part 3 to each other. Okay, this is our part. We have just saved all our parts to our assembly. This is for our welded assembly. We can just again resize our parts. I'm not going to create the part drawings for this part. This is our base view. This is our base view. Finish my sketch. I will move this to have a midpoint. This is for the drum assembly. We have all the parts and we can just manufacture for it. We will continue with the other parts. Okay, we continue our next part, which is the number 6 our part, the drum bush. It's used for rear purposes, and it will just it is between the drum welded assembly and the drum connecting bolt between these two parts. I will just start a new part for drum bush with standard inch, and for assembly purposes I will just save my part, which is number 6 drum bush. I will start a new sketch. For mounting purposes I will open the visibilities and center point visibilities. My part is a cylindrical part having these properties. The inside diameter is between, let me draw with red color. Inside diameter, it passes through this dimension, which is 0.375, and the outer thickness we will just give a fit thickness at this point. I would like to have this to be inserted in our drum part here. It will have the same length of our drum length, and here I'm going to make this drum with the tolerances here, which is 0.5, the outside of this dimension here, as you see here in our example, which is 0.5, inches, finish my sketch, have the extra tool. I will change the symmetry condition and the length. I will just get that length from the dimension, which is this one. It has 0 point, I think. Let me open that part as well. Let's leave as it is. I will just go to this assembly with right click, open, and to find the bush part, I will get the same dimension, which is 4.4. I will make this extrusion with 4.4 inches with symmetrical. I will leave this XY plane for mounting purposes. Also, when I open this one, I will again use the same XY plane visible for mounting purposes. The next thing, I will just create my view here. I will use this place, have the base view. This time we have not, I'm not interested in this part 6, or you can just go and find your part here, which is drum bush. This one with the top side. I will do something in this example. I will just shorten my view here by having this break command. I will just create this one. It is 2:1 scale. If you want, you can just make a smaller scale with 1:1, something like this. But it is not important because we are going to use this area. Let's leave it as it is. And I would like to make this view a little bit shortened about this one. Also, I need one thing about my figure. I will give a limit fit for these two dimensions. I would like to have this dimension with dimension properties. You can also add limits and fits under the dimension tool in the sketch. I would like to have a loose fit with showing the sizes and limits. This is a hole feature here. I have the hole with 7 tool. I will use this one. Have this one. Then I will need another dimension properties. Again, the size and limits. This time I'm not going to use a hole. This part will be a shaft part, and probably it has above. Let's use U6 for tight fit conditions for this dimension. As you see, it is bigger than the size, nominal size at this point. I will just use these dimensions. I will turn back to my figure here. I will create the break view first, but before this one I will just add two things. I will add the dimensions of our part. As you see, when I have given that dimensions in the technical in the modeling side, I can get those dimensions in here. I have these dimension I would like to have inside. I would like to have outside. The first thing that I would like to have is a breakout view. If you want, you can just use a breakout view. You can just pull the end lines to see our hidden lines like this. I will just move it a little bit. I will use these dimensions and make a cut break. I get the break option, select the view, and this time my orientation will be in vertical dimensions. The points that I get, which is this one, and I would like to have shorten this one. As you see, we have this gap. For this, I can just edit the gap between, let's say, it is the symbol here. We have the representation much more like this. With double click, I can also just increase the limits, let's say 10 millimeter, or shorten the limits by reducing this line like this. Also, what I'm going to do is I will enlarge. Yes, you can also play with these dimensions. I will have this one again. I'm sorry. I will have this gap about, let's say, 4 millimeters to show you. Again, I'll just extend the borderline for my part view in our sketch. I will just make the copy and make the paste, which is part 6 bush. This time I can also edit the break by having this, deleting this one and re-add it again, because it is a very short, this time we have a very short breakage here at this point. I will just get like this, from this point to this point. I'll just make another view by adding this outline here. This is the, I think we have a missing symbol here at this point, which is a circle dimension. We have missing symbol, and this is all for our part. Let's have this one. Okay, we will continue with the next part.
Our next part, the seventh part, is our pre-engineer, and we have already made it. I have just only opened this part. This part is under our folder, winch folder, the gear set, design accelerator, and the pinion naming, if you have done so. And we also had inserted our keyway and hole dimensions, all details to our part. We will continue with the next part.
Our next part is the bushing part, which we use to outfit in our assembly. And the dimensions of our parts can be just summarized, which is this one. It's a cylindrical part, and we need 4 dimensions to define those. And here we have a cylindrical part, actually like this. We have 2 different sizes. We have a bushing part, which is on the top side, which is used at this place, and the other one is also used at this place. We have 2 sizes. One is the dimension here. I will just create 2 bush parts for the actuator side. The first one have the dimension with 1 inches, the biggest diameter, and we have 0.1 inches of this height, and after that height we have a 0.625 with hole, and we have a 0.9 inches, which this profile, let me clear, we are going to just make the biggest bush here like this. We will just follow this profile and we will just make this one turn around this axis. We will do the same thing. Its dimensions are a little bit smaller. We have smaller dimensions, but the heights are almost identical. It is again 0.20 for the straight side. I think here this one, and this time we have the thickness. It is not amplified. I will just use the same dimension, which is this one. Again 0.4, 0.2. Let's open the first brush. We will just change the dimension. The first thing I will do the bushing on the bottom side, which is the bigger one. I have the 7th bush big. I will also update my part list. Open the XY visibilities. For changing the dimensions, I will just, the revolve section will be easier for us to make that revolve. I will connect the profile and make the trims and make this one construction. I will give the dimensions, which is the bottom side. We have 0.625. Delete. For this height we have 0.1 thickness, and for the other side height we have 0.20. It seems here. And I have the dimension, which is this one. It is fixed, as you see. It is, I have the horizontal constraint, and the dimensions for outside here we have 1 inch, the biggest one, biggest dimension from the origin. 1 inch. Also for the other side we have 0.9 inches. I finished my sketch, the bush here. I will just have this shape and save my file. For the second one I will only change the dimension. For this I will use, which save as comment, and change the number here, which is small. And this time I will concentrate this bushing on the other side. Yes. Here the hole we have 0.5 inches. This dimension 0.75, and the bigger dimension, which is 0.9. For this I will just go and change the dimensions. 0.75 on the top side, 0.9 on the bottom side, and 0.5 here. We have the same dimension, but this time this length is 0.2. I will use the same thing for other side. Finish my sketch. As you see, our figure has changed, and I will just save my part file. I'll create the 2 drawings, add to my part views. Here I will use 2:1 scale. I think it will be enough for this bush. I will continue this way, also this way. Yes, for this bush again I just create a, I'm sorry, I would like to have follow the same line on the other side. Also for this one I would like to have, let's make it a little bit smaller for the other. This is the small bush and I would like to add the big bush from the part list, which is part 7. Let's change its name with one empty here. Okay, let's create a bigger one. Yes. This time again I use the 2:1 scale. This is the bigger one. Again I add a border line for our figure. Let's make it smaller like this. Because we have some explanations, I will use that explanations for our parts. Let's make this one first, the explanations, so this one like this. This is the bigger one, which is part 7, bush, big. This is the 8th part, bush, small. Okay, the next thing I need, we can also define the tolerances for our pots. We would like to have inserted these 2 pieces hard into our part here, and we would like to have a free loose part for inside of our figure. Again, the same thing for our parts. For this part we will have a loose fit condition. We can add that loose fit condition also from this, from the sketch. We would like to have add a dimension with dimension properties. Here I've changed the fit. This is a shaft size, and for this I need, for example, let's say it is a P6 tolerance. Also, if I would like to just show the limits to my properties, I would like to have show the size and limits, which is this one. Also for this I need, this is a whole dimension, I need limits fits, which is 8.7. It will be enough for us for the limits and fits for the smaller one. When I just go back to my part, when I add the dimensions to our part, it will be shown like this. Okay. Let's organize a little bit more. Yes. Okay. 5.8, 5.08 times. Okay. The next thing, also, I will open the big bush. Do the same thing, do the same dimension, tolerances to this point. With right click, dimension properties, limits and fits. It's showing sizes and limits. This is a whole dimension with F7 tool, no problem. We would like to have a tight fit At this point we show the size and limits. This is a shaft size, and I'll change this limit, let's say P6 again, or N6. It's up to us. I'm sorry, N6 for our part. Okay, we have defined our tolerances on our body part. We can leave as it is. Yes, this is the dimensions which we have. I will just extend the dimensions like here. I will just move the dimensions. Okay, this is for our two parts. We will continue the next parts, which is number 9 and 10. Our next part is the pole in our assembly, which is the 9th part. You see this part. We also have a clearer version of this part. You see on the screen we have two sketches actually. One is the enlarged one, which gives us the idea, and it is about this area. And we also have other figure. Let's start with the sketch on the left side. The first thing we need to, in our sketches, we choose an origin for ourselves. I take this point as origin for my figure. I start a new part with standard inch IPT. Open an center point visible and XY plane visible. Start a new sketch with two lines representing the axis line at the origin point. I convert them to construction and stick to the origin point. I'll stick them to origin point. After here, we first create the other axis. The other axis is 0.6 millimeter far from this line. I start a new axis. I can also make this midpoint coincident on this line, and I give the dimensional constraint for that axis, which is 0.6 inches, and I will convert that line to construction. We will deal with this detail because this detail also has many things to be done at that point. We will add those details after we have created our parts. The next thing, what I'm going to do is I will just draw this outline, try to draw this outline, which is this one. I will start from this point and I will just go to this point and come back to this point because we do not have seen this dimension. Also, I would like to limit my part with 1 inch distance from the origin side. I would like to give that dimensional relationship. I put a line for construction purposes and give the distance constraint to 1 inch and make this one midpoint coincident on this line, and I will extend that line. Okay, let's start modeling. I will take my mouse back. Okay, at this point, as you see, we have a line here and we have a curvature with 0.1 inches. Let's start at that point. The radius here, I give the radius size 0.1 inches, and this curvature is tangent to this line and this line. I will just make tangent this curvature and this curvature to this point. The next we have another curvature which just comes from the other side of our part. We will search for that part. And these two circles are tangent to each other. We will just give that detail later on, but for this we are going to make the outside tangent like this. We will make a tangent constraint like this. And here I will just jump to other details. Let's have the undo command to clear. Okay, the next thing, what I'm going to do is I will just create the radius, which is 0.56 at that center point, which is 0.6 millimeter far from inches far from this origin line. I will give a tangent radius here, which is 0.56, and I will just have a straight line. Please have this horizontal constraint and make tangent this line to this circle. Make trim and also make tangent this line to this circle. Also make tangent this line to this circle. This line. I have the shape which I have desired. I do not need this portion because after this portion we will just go with this curvature. Okay, let's take the mouse back in the paint. The next thing, what I'm going to do is I will just go to upside up to this point. Okay, the next thing what I'm going to do is I will just draw a line and make this line tangent to this curve and give a dimensional constraint. We have, as you see, we have an angular constraint which is 50 from this line. It is the 50, and I will just make the trim for unnecessary portion. For limiting outside here, which is we have 0.24 distance constraint here. Also we have a 40 degrees line here, which is parallel to each other. I will just draw two lines, and I'm going to only use one line for my properties and make these two lines parallel to each other. Okay, give the inside line with angular dimensional constraint which is 40, as you see. Yes, and we have a curvature here which is 0.20, which is stick to this curvature which you see on the screen. I will make another circle having the dimension, right click, radius, which is 0.2, and make first tangent to this one and tangent to this one, and I will just trim the unnecessary parts. As you see, yes. Okay. The next thing, what we will do is we will continue. I'm sorry. I will take my mouse back to have a clear shape. I will just go outside. Yes. From this point, we have again the same curvature which we have at this point, and it is 0.24 far from this line, and I will give again distance constraint. I have forgotten this one. We have a distance here, 0.24, far from here. Also, what I have more. Anyway, we will continue later. This one, that one, that one. Okay. I have another line constraint. As you see, we have again another line, also arc shape. This time it is equal, this one, this curve, and this curve are equal to each other. This curve is tangent to this one, this curve is tangent to this one, and we have again this curve. We also have another curve, which is this one, and this curve is equal to the 0.1 inches. These two curves are equal to each other, and I will make tangent to this one, tangent to this one, and I'll give the distance constraint, which is, I'm sorry, this is not like this. I'll again draw a circle here. I will start the circle, make tangent from the line here. I will trim the unnecessary portions, a little bit cleaning needs. I need this time. Okay. Okay. Also, I need this clearance. I'm going to use first split. As you see, we have split it, but it's still moving. No problem at all. And it is tangent, this line is tangent to this one. I'm sorry. On the other side, we need that tangent condition. I'm not going to use this line. I will just make tangent to this. Also, I will create another tangent condition with delete for the outside here, which is this one, tangent to it, and I need an equal constraint, this one, and I will need a dimension constraint between these 2 points, which is 0.24. Okay, then I will just create a tangent relationship between these two. Okay, let's make the trims. Also, this trim will just end at this point, as you see, and I would like to have extend the bottom line till to the end and make this line end coincident on this line, and I will just make the trims for unnecessary parts. As you see, I will just split and I will just convert it to construction here. Again, I need a tangent constraint here. I need this one. Okay, let's make the trim for unnecessary parts. Again, what I need, so here I'm going to use this portion, not this one. Also this portion I'm not going to use. I will just convert it to construction. Okay, we have made most of the parts here. I will trim for internal parts. Let's make 2 circles here. This one is 0.38 which is on our origin 0.38. Also, we have a bigger detail. We will add these details from this sketch. I will just move my sketch like this. At this point, we have an outer diameter here, which is this one, 0.75, 0.375. Sorry. We have two axes passing from this line. Also, one axis more here. We have two axes. This is this axis, and I would like to just create one axis more. Again, from this side, I will create two axes, and I will give the dimensional constraints, which is this one. It is 35 degrees. I'm not going to use. Also, this is this dimension. It is 35. I'm not going to use. But for these extensions, I need some dimensional constraints. I will take my mouse back on the paint side. I will just create two rectangle or circular commas. It is a rectangle, something like this. We have a shape like this. Also, we have another second shape which is rotated like this. We have a rotated one, also for another rotated one, like this. But I will just do with the lines. I'm sorry. I will just make this one constraint and convert it to construction. Yes. Next thing, we have a line which is 0.20, and I would like to keep this point at midpoint, and I would like to give this dimension with 0.2. You can also create. Also, I would like to have this point passing from this line and make this one passing from this line. I will trim this portion. It will just keep the inside, I think. Yes. It is symmetrical, as you see. We have 0.2 and 0.1 on one side and left 0.1 on the other side. This is our part. And from this point we also have another 0.2 here, which is a line like this, having the same equal length with this 2, and this line origin point is on this axis, and it is perpendicular to this line. And also I would like to have this line end on this point. As you see. Okay, the next thing, which is this one. Yes. Okay. The next thing, what we have, this is the diameter. Yes. Also another line having the same length. I use equality. This one and this one. I use the midpoint, stick on this line and make perpendicular to this. Also, I would like to have that line stick on the axis line, which is this one. Okay. The next thing what we need is we have actually I think this dimension is not true, and we would like to have a bigger shape like this. I think this dimension is not true, or the other side dimensions are not true, because we have this line outside of it or tangent to it. Let's forget this one. Okay, let's have another line. This time its length is 0.2. Again, I have erased the equality between the lines. Make this line on origin. I would like to have tangent this line to this curve, okay, and make the equal, make the other side equal. I would like to have those line relationship again, make this line equal to this one, perpendicular to this line, make coincident on this line, and I would like to have this line on this curve. Yes, not this one. Again, I can use the tangent constraint to this to have the shape. Also, for the other side, I will do the same thing, but I can copy by using the circular command, which is 2. I'll just change, and I would like to have with 90 degrees. Let's create one. Let's edit, change the other side, -90. I'm sorry. Let's delete this pattern. Circular, this one, this point, 90. Yes, with 2 relationship here we have. And also I would like to have lines passing from these points, and these lines are perpendicular to our figure. So this one perpendicular to this, and I would like to have the trims for unnecessary parts. I think we have a mistake here. This 0.2 inches are not true. For this I will extend these lines, not symmetrical around. Let's delete this one and create it again. Also, I would like to keep this line. Again, a line here, perpendicular to this one, stick onto this, okay, tangent to this curve. These relationships are enough for creation of parts, yes. Also, I would like to have, if I have the equality here, no, then I would like to have a line perpendicular passing from this point, and this time I need a dimension from this point to this point, which is 0.1. Yes, trimmed. This is not symmetrical, only 0.2. It's my mistake. I would like to have, I'm not going to use this one, this inside. I would like to use that extension. Also, I need these 2 lines for cut purposes. trim the unnecessary parts. Also, I need a line perpendicular to this, tangent to this curve, and extend to this point, which is going to be trimmed. Okay. Yes. Anyway, I'm not going to use this one. And this dimension is 0.1. And I need a line perpendicular to this one and make the trim. Okay. Let's get rid of this one. Anyway, I'm not going to use that one. Trim. Okay. For this, I lost the symmetry condition here. Continue to trim. Not to trim, maybe split will be a good solution. I'm not going to use this section. Also, again, split on the other side. It will be also a good solution for this. Okay, the next things, split for other parts. Yes, I'm not going to use this section. Split again, this side I'm not going to use inside. Again, I will just define a symmetry condition to fix it again. Split, also another split. I'm not going to use this section. Anyway, yes. Yes, we made it. This is our part. Also for this one, if you want, you can just make the trims for our figure. Let's check our figure. And we have the sheet metal thickness at this point, which is 0.375. This is our part. Let's save our part, which is part 9. Part 9. Dash Paul, and I have the extra tool. Get this one. I mostly prefer to keep, which is the thickness 375. I mostly keep the thickness between these two. For this reason, I will use the symmetry conditions. I will just save with OK. Save my file. Okay, we will continue the technical drawing. We continue our part drawing with the part 9 pole. I will just change the file and just create a view of this pawn here. We have only one open file, which is recently this one. I can also just select that file from this point. I will have this point, and I will add a border, part border, like this for our part file. The next thing, I will add the axes. We have 2 axis lines. I have extended this. So take this out and retrieve the model dimensions, which I have here. And I will just move them inside of our part and organize those dimensions. Like this we can extend this up to this point. Yes. I can have, which is this point. I can just leave as it is, or something like this. And we just organize the axes. These axes we are going to just make on the detail view, which you see in this one. I will have that detail view, and I will erase some dimensions from the original view, the base view. I will just delete parts here and only leave some dimensions for our parts. Yes. The next thing, I'm going to give a detail about the part. I would like to have this detail. If you want, we can hide that detail by having another copy of this part. I will just copy of this again, paste, and I would like to have this time a crop operation on this view. I will just make a crop in this view, except with this one. I will just make another base view. Sometimes it will be better for us. I have, yes, this part we have, it is the same view, but I will just crop some details. This is another way. Here we can just make and close the visibilities of our parts. Visibilities, yes. This is the detail. I would like to have the dimensions. Only this at this point we have only necessary dimensions, and we can have a leader to just write the text details detail view. We create this one, and I will just extend the lines as we have here, which is this point. Again, I create an axis line, and I'll arrange the dimensions. So I will ignore this dimension. For this one, I again add a detail view, add a vertex somewhere for this one. Again, I add vertex somewhere to this point. Add with enter. Add, I'm sorry, add vertex to this point. Get a point here. Anyway, we have the detail view. I again adjust this part border, and I will just write the details of this part. Will paste on this one, and it is 9 dash pole. We will continue our next part. Our next part is number 10 with spring holder part. We are going to start designing this part. As you see, it's also a bended sheet metal part, which you see in this on the screen. I'm sorry. We have a bended part like this. We have two different bends. Also, we have a degree bend at this point. We have a 90-degree bend at this point, and I would like to have these shapes. Also, I would like to give the outline for our part. In these kind of parts, we will first design the basic shape of our sheet metal part by using these dimensions. Then we will just decide our part, which is this one. As you see, we have a dimensional constraint. After this creation of the main profile, we will try to give the shape of our part by having cut and extrusions. Let's start. You can also just create this part with the normal modeling, but normal 3D modeling. Then you can just convert that part to sheet metal, or you can just first start a sheet metal part. I'm going to start a sheet metal part properties. I'm not going to deal with sheet metal property. The first thing in sheet metal, you have to set up the sheet metal defaults, which is this time we have 0.2 inches with the thickness of this spring holder. I'm going to change the thickness. The next thing, what I'm going to do is I will create a sketch and choose an origin point for myself. As you see, we can just create many points for our origin. And for my sketch, I would like to just select this line and this point and also this point as origin for my figure. I've opened the projection, origin folder, make two items visible and start the sketch at this point. From the top side, I will go to 0.5 inches with 90 degrees. Also, I will just go to the bottom side some degree, and after that one I will just like to turn with 30 degrees here. I will define the dimensions first of all. This time inside the dimensions, which is this one, 0.5 inches. The height here, which is 0.24 inches. Also from this point we have 1.2 inches, and we will just create, this time we have 0.24, and we have a dimensional angle constraint, which is this one, 30, and this length, this is a special length command. You have one time, again click on this line to give its dimension. It is 0.24. This is important. We will first create this one. If you want, you can just counterflash. As you see, the thickness properties just came with this. Also, I think we have a missing dimension. I think 0.02. It is written wrong. I will change this one. Yes. Again, this time, yes. Exact. I think we have a typo at this point. As you see, we have the bends in our part. As you see here, we have a sharp bend, but normally we cannot bend something like that. We also have the sharp bends seen on here, and if you want, you can also change the dimensions, but this time we will just have only the inside profile here. We have the inside profile drawn. And here what I would like to create is, I would like to have a dimension relationship which is between this one and this one, this point and this point. For this, I will just make a simple calculation, or if you want, you can do this one, because we have the profile, but we do not know how many millimeters we have to just extrude this sheet metal. Also, I would like to just change to keep the mid plane in the center point. Let's calculate. We have a 0.34 inches, and after that 0.3 inches we have 0.6 inches more. I would like to add 0.34 plus 0.6 for one side. I will just get this equation into parentheses with multiply for each side. This is my part. What I'm going to do is I will just give the shape which I have seen here. What I'm going to do is I would like to just keep, this is my origin point, and I would like to create the shape here. I start a sketch on this face, and I would like to just create the first thing, this one. Also, first axis to have the dimensional relationship. Also, I would like to just add an axis line. I will use this line for mirroring purposes. I will mirror this rectangle by using this line. To apply and done. Here what I need is, we have 18 inches between these two lines. 0.18. Yes. This time, at this point, we have a curvature here, but I would like first need these one axis. I will create a line. Let's pull this one. Construction. I will just give this dimension, which is 0.34. And this line must passes through this origin point here. What I need is, I would like to have a circle which has 0.6 inches, or I can just get that dimension from that one. This place. I can use this place. Let's try. We will just give the radius, which is 0.6. Yes. And at this point, we have 0.6. I think, yes. Okay, let me check. This is 0.6, and also have, I think we have a mistake at this point, which is 0.3. Let's have this one for this tangent relationship. Let's try this relationship. Also, after this one, let's check this one. 38, the inside of it. Let's try this one. I'm sorry. I will delete this one. Delete also the relationship between the lines. Again, 0.34. I will give, let's have tangent constraint to this point. Normally it will be, yes, exactly, this point. But after this point, I have a straightness which I do not know. That is, let's call this one, which is this point. Okay, anyway, we continue later. And after this point, we will just continue straight to the bottom side. Not straight, we have a dimension relationship again straight, and I would like to have that dimensional relationship which is (0.1 to this point, and I would like to create a relationship here which is the point I have created in my figure. I will open that sketch visible and get that point with projection, and from this projection with F7 tool, F7 tool, as you see, we will extend the line. I'm going to give the dimension, the radius here, which is this one, and this radius is 1.4, and I would like to have my center here on this line having the radius 1.4, and I would like to make this circle tangent to this one. Yes, we have, actually we do not, this dimension, our circle here is not at this point. We have a circle on this line, its dimension, I'm sorry, I made a mistake, 0.6, and make this line tangent to this line. Okay, and after this curvature, maybe not this one, we have somewhere here, yes, I would like to have a tangent this point, but this time it is not very certain about this one. Let's extend this counterflash much more than this length, because I have made a mistake. I realized that I have made a mistake. This is much more than this one, and I'm not sure about this dimension. We probably have this dimensional relationship. I will just leave it as open. Let's not this one. Leave it as open with, let's say, 3 inches, as you see here. And I would like to just create a good dimensional relationship between this curve and this curve, and I will just edit my last sketch by deleting this dimension here. I will just move my figure here and make tangent this curve here, and after this touching curve here, we will just make a tangent to it. Okay, this one, let's create, anyway, we would like to have, anyway, let's create 3 curves this point, which is 0.38. Its radius is 0.38. Yes, this one. Its dimension, I'm sorry. Divided by 2. I will just delete it. Well, 0.38. Again, I will create 2 circles more and 1 circle on the other side. Okay, another line circle here. I will just give the equality condition here. Also create another circle having the equal dimensions of these 3 to each other. This is equal to this one. Also make this circle on this line, and I will just create another big circle, not in this midpoint, somewhere here. I will make this circle tangent to this curve and give the radius dimension, which is this time 0.75, which is this one. I will just delete the unnecessary part. I will just trim this one, this one, this one. I do not need these items. I do not need either. I'll just go and delete the unnecessary things. Also these lines I do not need. Okay, this is our part. I cannot solve this problem. Let me leave as it is. We will just decide the other side. I will have to investigate that dimension. Okay, anyway, we will continue to this our part. With which dimensions I have to follow. 0.6. Let's give this one. I think we should have to use the same radius. This is the dimension. I think this is also, let's try that dimension, which is 0.6. 0.6 here. Let's have that dimension on this line. Probably this one. We have again a typo at this point. And from this point, let's ignore this one and make this tangent to this curve. Yes, exactly. Again, tangent to this curve. Make this extension. If you want, you can just stick to the top of this face by using this line constraint. We have F7 tool, as you see here, and from this point we do not need any portion from the top side. We will use for this for cut pieces. Also, we will use this region. I can extend the 2 lines from this point here. The trim, I will use the trims. I will use this point as a trim point, and I will just close this area, this loop area, as a cutting area. Let's make this one a little bit more better at this point. Yes, we will cut some areas inside and we will mirror to the other side. I'm going to just use trim to work it much more clear. I will trim this curve. Okay, I will use these areas to just make the cut operations. Here, what I'm going to do is I will just create a 3D model with extrude. The first extrude cut is in this position with through all dimension with this symmetrical constraint. I will cut all the things, as you see. When I use a sketch in the revolve section, I will lose this one. To use it again, I will make it visible from this point. The next thing, I will add some extrusions, which is this face. I will just cut, which is this face. I will also cut, which is this face. I will also cut. Yes, the points which we have here. I would like to use the other cuts. This cut extrusion that I do not need here anymore. I will close the sketch visibility. I'm sorry. I need this section also. I have to add that section. Here we have our part. The next mirror thing, I will use this extrusion to the mirror plane by using the plane in the middle side. We have this section here. The next thing, we have a hole on this face and we have a fillet on this face here on this corner. I'm going to make the fillets, which is the radius 0.2 at one side. Yes, I realized that I made a mistake in the extrusion sketch. I'll just make that sketch with not 0.1, 0.2. Make it a little bit extended. This time, yes, exactly. Let's check our profile. I again go to fillet tool, change my view orientation and get this point. I'm not going to sketch to get this curve cut here. I will use the fillet tool with ease. Okay, this one. From this point, we have a 0.12 hole on this face with the dimension far from this edge. I will just create a hole, or I can just create a sketch, which is I'm using this time this face. I get the geometry and I create a line. I will just draw a line which have the properties, this is the property of vertical, this is the property of horizontal, this is also horizontal we get, and I will first make this one. To make a tangent, I would like to create an extrusion sketch with a dimension which is 0.12, and I would like to have this point on this line and this line to be far from the tangent edge, which is 0.12. I will just make construction, 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 and construction. I will use this point, and if you want, you can use the hole tool. If you want, you can use the extrude tool. whichever you want to. I'm going to use the hole tool. At this point I would like to have, we do not need a tapered hole, threaded hole. I would like to just keep to through all. The diameter I need is 0.12. This time I made this hole by hole feature. The next thing what I'm going to do is I will just create a flat pattern by using one command. As you see, we have bended edges, bending edges, properties according to my figure. You can just, this is the command we use for flat pattern. We go to the folded part and our part is partly finished at this point. As you see, this is our part in all dimensions. Let's save our part. This is our part 10 spring holder. This is the part we need. Save, and I would like to have change and create a new part view. From the place menu I will just have the spring holder. As you see, we have a dimension here. I can just make a smaller scale with 1:1 and with another view. These are for our folded part. As you know, we just move. Also, I need a flat pattern view. Again, if you want, you can just use. I need a flat pattern view, which is this one. I need a scale to 1:1. Let's say, yes, this one. 1:1. First create, then move it. I will increase the border, edit. I will use this border and trim sections. Yes, this one. For copy, our description. For paste, it was, yes. Next, let's take it back. For copy and for paste, we have the box. This is our part 10 spring holder. This is 1, this is 2. I will extend the lines. I will give the dimensions which I have seen here. If you want, you would like to have show your bending axis with double click, especially this side. With double click, we can just tangent edges open and to see that foreshortened. This time we have the bending sections respectively better in shape. The next thing, we have an axis line, and I'm going to use this axis for this purposes. I will just retrieve the model dimensions, also other model dimensions for the thicknesses. I will just delete the unnecessary dimensions. This one we will need. This dimension here I need. This dimension I need at this point here. We have the thickness information. We can keep as it is. I can keep this information. We have the only organize the dimensions which I have seen in the technical drawing during our modeling. For this we have an axis line to imply. I will just create an axis line from the bisect center line properties. I will extend this one. Also, I would like to have that dimension in this view. We have a whole dimension. If you want, you can show this one, or if you want, you can show on this slide. Okay, this is the dimensions we organized. For our banded part, we can just change, add the views. First we need the total length. I need the other things. We need the bending axes, different distances from each end side. This is also, I need the bending lines, bending line properties. I would like to just move this one. This is the bending line. I'm sorry, the bending axis. Let's leave as it is. If you want, we can, yes. This time we can show. We have the bending radius here. We have the bending dimensions. For other lines we have also for this. Okay, let's have the text tool. I would like to just have the text tool instead. I'm sorry. I can just use this dimension. It would be better, to much more understandable. Here we have a radius dimension here. As you see, if you want, it will be better to have this diameter. So we have this dimension. Also we can show this dimension on the other side, which is this one. Okay. Also the next dimension, this is the dimension I'm dealing with. This is the dimension I'm interested in. Also, I would like to give this dimension side view. And also I would like to have the dimension here, which is between this circle and this circle. Or you can just extend this line up to this point, as you see in the drawing. You can use these, sometimes these properties. We use this one. We have a radius here. And also we have a thickness value here. And I will extend that value, this line, to a line somewhere here. Here, yes. We have a arc shape, which is this one. I will just move this view a little bit further. I can delete this line and give that dimension. If it is not given here, I can just use this dimension to define the sheet metal thickness. Okay. This is the part we are dealing with. We have added all the dimensions. The next thing, we have the part 11 at this point. I save this part file. Also the other file, I'll just close this one. Okay, we have the spring afterwards. The next part in our assembly is the spring, which we use for tensioning purposes. This is an extension spring with outer diameter 0.24 inches and the wire diameter is 0.025 and the free length is 0.5 inches. In inventor side, we can just create these dimensions by these equipments by using the assembly tool and design parameters. I would like to just show you first our design parameters. We can create compression springs, extension springs, bellow wheel springs, and torsion springs as well. In our case, I have to save my part to create this spring condition. In our spring case, we have many different parameters to just define. For this reason, we have to just calculate or just create our part with the normal conditions. For this, the most important condition we have given is the outer diameter here, which is D1, the wire diameter, which is D, and the free length, which is LO or L8 here or LO here, which is our dimension which we have defined in our spring case. You can also have, if you just use this extension spring generator, I have tried with the same values, but it didn't work. For this reason, I will just turn back and create on our design. I will just close this one and open a new file this time. I will just create a new file and I would like to just create my part file in the inch directions, in inch units. I have 3 coils here. I would like to just create a coil command, and I will just create the ends according to our needs. Okay, the first thing, again, I have just chosen or open the visibilities for our part, and I would like to have a primitive design. The free length of our part is just defined as 0.5 inches, as you see. It was free length, it is defined. And the next thing, what we have is outer diameter of our coil. We have 3 coils. I would like to just make the copies. I need 3 coils in this direction. And I would like to have at least 0.25. Let's first give the wire dimension, which is 0.025, which is this dimension, and we have an outline. I will turn this to first construction, then the center line, and make this aid line. I will first make this one construction, and outer dimension here I would like to have, which is 0.24. The next thing, what I'm going to do is, I need 3 copies of this part. We do not have too many parts. For this, I will just create 3 more items. Otherwise, I can use the rectangle tool to make the copies. For the most case, we have the tangent relationship and having the same dimensions with these 2 coils. Okay, let's have this one. We have the primitive design. Also, I would like to just define this tangent relationship to outer this circle. I will just move this one and make this circle. Also, as I have told you before, we have some hook dimensions like this, and in the spring coils we will just would like to have a curvature, something like this. I will just follow a line, something like this, and I will have a line here, make this line tangent to it. Let's trim. And after this condition, we will just make the coil attached to this point, which is something which I will have a relationship, something like this. I will just make the tangent to it, and I would like to have a curve. If you want, you can just create a curve, something like this, or if you want, you can just move this curve to center point and have that curve here. What we are going to do is I'm going to just make a pathway for the tool which I have here. I will like to make coincident this point on this curve here. As you see, we have a full constrained coil here. I have 2 coils, 3 coils. I can increase the coil sizes like this, and I would like to use this path to have the coil sweep path. I will just make the trims and convert these lines because I'm not going to use. Also, I would like to make equal these 2 curves and make tangent to each other. Yes, I'm sorry. This one I would like to use. Yes. Also, I can just make a fillet command, which is, or I can just use a transition circle tangent to each other, and I would like to use that curve for good dimensions. I would like to also make this line tangent to this line, and this pathway I'm going to use for coil purposes. Okay, that's this. Ignore this one. I'm not going to use this one. I will just split this line. Do the same thing for the other side. I will create a new line somewhere between the midpoint of this line. I create a line, make this point somewhere at the midpoint, or you can just simply give the dimensional relationship, which is this one. Okay. This line I'm going to use the copy of the hook on the other side. As I told you before, we have tangent relationship between these parts, and we can just separate these parts from each other like this. We will have a shape something like this. And also we need on the other side have the mirror of this pathway by using on the other side. I'm sorry. Again, the mirror, get this path, this line, I need this line also. The mirror line here, apply and done. We have, for this one, I will need the mirror of it. I will use this time this mirror line, also this one, apply and done. Here what I'm going to need is this line to be at this point somewhere here, as you see. Yes, exactly. And also the third coil is between these 2 lines. I will create a new line, convert these 2 lines to construction, and make this point somewhere between. I will just create a simple model for my part. For this, I have this coil and I have this coil. Actually, I can ignore these two circles, also this one. We can use the other way around. We can also have this one to be mirrored on the other side. The first thing I need is I have these coils, and what I need is to define the geometry here, which this time it is about 1.8 times this one, this size. I'm sorry. The wire size 0. I'm sorry, the outside diameter 8 with this sign. I will just multiply with this coil if it is not so much. Let's create a 0.5. I'm sorry, 0.1 inches, like this. Also, I would like to have, I'm sorry, I think we have, I can just move my line to here, somewhere here, which is again the wire size, which is equal to this one. Yes. And also we have another side. I'll just ignore the pathways here. Let's ignore this pathway. I will draw that pathways again. I will use and trim this pathway and this pathway. And I will extend this line, trim the pathway on the other side. We have a compression spring, and I would like to just carry my line, this line, it is between the two lines, and I would like to just make my line, the circle tangent to it, also another line, this time tangent to it. Also we have an outside line. I have deleted that dimension, which is this time 0.24. Yes, and make this curves tangent to it. Okay, I would like to have use this coil sizes for this basic design. This is the free length. Since it is just moving, we can just think this time a little bit different. Also, you can just define this length from this point to this point, or from this point to this point, also 0.5. Then this time the springs are all attached. Let's leave as we defined before. Here we have the copies, and we can just continue this curvature, and it can be at least equal to this size, and it is tangent to this curve, tangent to this line, and we create a simple line with trim. I'll just stick to it, and I will just create a new line up to this point. As you see, we will continue for sweep operation for this. Do the same thing. I will do the same thing for the other side by using this line. It is also passing out. I can just create a new line by using the mirror tool, this one, this line, and use this line, apply, and done for the other side, as you see. and I'm going to just make the split. This time I'm not going to delete also the split command by using the construction as this. Okay, we will start and end at this point. The coil size, I can just tell the coil dimension, which is 0.38. For this, the first thing what I'm going to do is I will just create a coil with profile. I need a coil profile, which is this one. Again, start a new sketch and get this basic design coil dimension. Also, I need another sketch again on XY plane and use this geometry as a coil geometry. I will ignore this time. I create a coil. I have the profile and I define the axis, and this time we can have some parameters which are seen on the second tab. This time we have the pitch, the distance between these two coils, which is 0.038. Also, again, we have too many parts, two sections. Again, this one, as you see, we have a pitch and revolution. I need 3 revolution with the pitch size, which is 0.038. Let's try this section here. Yes. We can also give decimal numbers from this. We can have the 2.5, 2.8, 2.9 for axis revolution here. As you see, we have just created our coil. The next thing, I will create a new sketch on XY plane and get the sweep geometry here. I will get the sweep geometry. I will just use this line. Also, I would like to have this line because I'm going to just go, and after this point I will just go straight here. I will close the geometry here. I will create, okay, this time, still I'm in the command. I will create also here visible. I would like to have again a projection geometry like this. I will close this geometry, also another second line, delete with F7 tool. I will just go straight up to this point because I will just combine these two items together. For this one, I'm going to just create a plane for my spring. Finish one. I will just create a new plane, which I will create a new plane at this point. I'm looking for a parallel plane, which is exact plane. I open the visibility, start a parallel plane through point. I select the parallel plane and the point here. The next thing, I create a sketch on this new plane, which has, this time I need the projection geometry to start with, or I can just get this point. Also I have previously in hand. This time I have the geometry, which was 0.024. I have the spring diameter 0.025. This one, and it is moving. To fix this one, I will make this one coincident a geometry at this position. I will get coincident on this. Next thing, what I'm going to do is I will sweep first this one. This is the profile we get. We have the path which is defined like this. Okay. We have the profile like this. And I will just revolve and add to this one. For this, I will just delete my coil. I'm not going to delete the sketches because I have previously designed. And I will just change my sweep profile up to this point, and I will delete. And from this point, I will just go around to the top side. I will just delete that profile and I will continue with the other side. Here, what I'm going to do is I will start a new sketch at this point. For this, first I made a point on this plane by using a spherical center point or center point of loop of edges. I have just put a point here because I need a geometry to sweep on with F7 tool. I need a coil geometry. This is my center point here, which is the origin point here. I'm going to use that origin point to get the dimension which I would like to have. The outer diameter here we have 0.24, but we have a wire dimension here which is 0.024, and it is tangent to this curve, as you see. And after this point we will make the cut. I'm sorry, I have just made a mistake. I will just create my sketch. First the plane, I'm sorry. I will create a parallel plane parallel to this plane through this, passing this point, and I will just redefine my sketch. I will just move this up and I will just redefine my sketch at this point here. With F7 tool, again start sketch with F7 tool. I'm sorry, from the top side I see here. What I need is I would like to define a pathway which is starting at the midpoint of this and make a tangent line to it. I would like to have a curvature to continue for our paths. I would like to have, if you want, you can also define a pathway as you wish, like this, but it must pass, which at the midpoint of it also it must pass, it must tangent to our profile. We will have a something like this, and we can just define a radius, let's say 0.5 inches, 0.06, I'm sorry. That's this one. I do not need this geometry anymore. Okay. trim this time like this, and after that we reach that point, we will have a normal line at this point. I will just make the trim also split. This time we have two lines, and I would like to have this line on this end. For split I need which is this one, and after this point, after somewhere here, I would like to turn back now my normal profile. I will trim this profile. I ignore this one also for construction. Here what I'm going to do is with F7 tool I will create another path on this way with a half profile. I need a sketch on this one. I get the geometry of it, which is this geometry. Finish my sketch. The first sketch I would like to just clear the unnecessary pathways. I need this, I do not need this one. I have the profile and I have the pathway. I get the sweep tool, we have the profile and we have the profile. At this point we will have this curvature, as you see. Okay, we have created a spring revolving around this one. Okay, like this. We will just use this path. Okay, from here I will open this visibility. As you see, we are just back on this path. I think 0.04. Let me check this path profile. Okay. Okay, from this point, the sweep ending, I would like to have that ending advanced properties. I'd like to have this ending or this ending type like this one. Okay, anyway, I'll just complete that profile. I will close the plane visibilities, also this visibility back. Okay, we have a turnaround at this point, and I would like to have this plane here. We have continue our coil from this point. Okay, the next thing, I'm going to just create a coil profile and add to this point. We need a coil, but for this coil I need first a sketch on this plane. I need a profile like this, and I would like to have that profile at the midpoint of this curve here, and I would like to just stick to on this line, and I would like to have the wire dimension, which is 0.024, and I'm sorry, not at this point. I would like to have on this line with the dimension from here, the outer dimension. I will just create a line property construction. This time it is tangent, the dimension here, which is 0.0, the dimension from this point, a line here passing from this midpoint. I will use this line for right click, select another curve, yes, this one, I'll turn this to center line. From this one, right click, select another curve here, just 0.024, and this time I have this dimension, which is it is on this point, as you see, which is 0.024, like this, and I would like to have this point on this line. Finish my sketch. I will just make the adding this portion to it. The next thing, I need a coil. For other sketches I will just close. I need only one profile, and also I would like to keep this profile as simple as it is. I need the construction. Also I need this construction. Finish my sketch. This time I need this one. I do not need the other profiles. Also this one. Okay, I need a coil, an axis. It will go to other side. I need 0.03 with 3 inches. Let's have 3 revolves, and I would like to create a solid part with a new part. Okay, like this. I will just heal this position by adding this up, or I will just change my profile, the sweep profile, which is the second one. I would like to just make this profile a little bit shorter this time. I think if I have just subtract 0.024 times 2 may heal this fault, or just 1. Not this time. A 2, 1 will be enough, I think. Yes. Okay, this is the other part. Also this one is the other part. We can have the connection. We can just connect these two items, especially with the sweep tool as well. Or we can just combine as it is. This time we can have the tool body. As I said, we have one solid figure here. Also, for the other side, we will just go back and add the same things for the other side. Let's first create the first sweep mirror by using the mid plane. I'm going to create a mid plane at this point, which is parallel plane, this plane, parallel plane through point, this point. I need the sweep. Before the combining operation, I will just delete 2 combines. I will just make the mirror of the first sweep, the mirror plane, create a new plane through point. I will use this point and this plane, create a new plane for the copy on the other side, create the first sweep, use the mirror and have the solids. also on the other side. If you want, you can just make it turn around or combine for the other side. This is all for our representation. If you want, you can just add the same things which we did on the other side, and we can just cut and make the properties as we wish, as you wish. Here we can do the same things for the other side, and we will just combine the things. The next thing, I can also get the mirror on the other side by using this one. Let's combine that tool as well. Okay, you almost have the same thing which we did. We can intersect, or we can just combine the parts into each other. Also, let's make this one, I think, intersect with this solid. Let's try. I'm sorry. Take my move back. Okay, this time I need the coil. I would like to add this coil, join to this solid, to the solid here, combine, do the same thing for the other side. Or I can just make a copy. I will just delete these. I need this work feature. Delete the other mineral tools. Just make the delete first, delete the second. I will just make a split operation by using this one. Split tool. I need trim solid, which is this solid. Let's try again. Split solid, trim solid. I need the trim, and the solid here I need is this one. Okay, we have a trim here. I need the mirror of these two solids, which is, this time I need the mirror of the solids, which is this one. Using this plane, I have the other side solid here. Okay. Visibility. I'm not going to make this for the part modeling. I will save part 11 spring. Okay. The most things in the technical drawing which I would like to show is this one. I'll just reduce its size like this. Add this portion, again drawing border, finish my sketch. I will copy the description, paste here. This is the part 11 spring. I'm going to give some dimension relationships with annotate, which is this one. Like other type, I can just create the basic tools, which is the free length that I need. First, the coil dimension, I can give that dimension, which is from, I can even make that, give that dimension from this point. I can just do dimensions for production. Also the diameter here, I will just give this diameter information with symbol of diameter. We can also heal our profile, but it's a normal working solution. If we have defined the details of the spring here, we can also make this one. We can just define the same thing, same expressions, which is this time extension spring. Which outer diameter is extension 0.24 OD wire diameter, which is 0.25 inches. Again, free length 0.5 inches. Okay. This is the dimensions which we have. We can also heal. I think I'm going to add the corrected one to your submission. This is for the other part, and we will continue our part modeling with the handle pin and the handle bush afterwards. Our next part is the bush part, which we use in the handle group here. Also, we are going to design the pin part, and the fit condition is RC8, which we would like to have is a loose fit, because when we are turning this handle around this axis, we would like to have a loose fit in order to just turn this handle easily by the help of the hand here. We will also have, as you see, we have a brake section here, but in our figure we are not going to deal with that sections because we have enough space in our technical drawing page. Let's start with the first part, which is the pin. And the pin size at the far end here, we have a threaded part here, which is 0.31812 with 18 UNC thread. I will just start a new part. First, I will just save this part, which is this time it is part 12. And it is the pin, handle pin. Handle pin. I have opened origin part and choose my part visible and have the XY plane. This is an easy part actually. We have 3 extrusion on and on. We can use that type of modeling. Okay, we use this section, start a new sketch. At this point we have a diameter, nominal diameter. We will just add a new thread. This time the dimension it's the nominal dimension, which is 1, 2, 3 thread size, and the thickness is 0.25. I have the extrusion first, and our extrusion is 0.25. After this one we have a fit size, as you see. Let me clear a little bit. We have a pin going on after this section. We have a height here which is 0.6 minus 0.20, which is 3.4 inches. I will add that section again. First I need a sketch. This time I need a diameter which is 0.375. finish my sketch, add the extrude tool, and this time I will just make this extrusion with 375 0.375 inches. 3.4 inches. And after this point, I will just move my back. I will have an outer diameter which is 0.5 with 0.20 thickness. After this point, I add another part. I will add this part. The diameter is 0.5 and its extrusion length is 0.2. Thread I add. This is the ANSI U and V thread, and here I will change. It's 5 to 16 with U and C dimensions, and it is a full threaded size, as you see, with a full threaded size which is 0.5 to 25, which is the handle width here. And I will add this one and save my second pass to my second file. After creating this drawing in our figure, I will just go and find my handle pin, open this one. This time my only one will be enough for our sketch. I will use 1:1 scale because it's too big for our part. If you want, we can just make a break view here, or we can just make it crop. Again, I will just draw a drawing layout, copy a few, copy and paste here with 12 handle pin. This time we have the diameter dimensions. I'm going to make annotation. First thing, I will just create a extension line here, the axis line, retrieve the dimensions. Here I will just organize them. I'm not going to use this dimension, I'm going to use the thread information about this two sizes. Yes, this is the actual size of our part, and this will be all. I will just turn this to this side. I will just follow on and on the dimensions. Also, I will organize this one, change this to this direction. This is, I save this file. The next file we have, I'm going to create a bush part for this handle push. Start a new part here, and also its thickness is 0.75 between with RC feet, which is a loose fit. We can just choose a D7 or D8 or A8. It depends for our part here. I'm going to, it's a simple part, start on XY plane. I would like to keep the midpoint for mounting purposes. The smaller diameter here is 375, and also we have 0.5 with the total height extrusion with this change this symmetric size, and I will have 3.5 I'm sorry, 3.4 inches for this bush. I will just go and save my part file with the names handle bush. I'll change first the number, then the name. Also, I will go and create a technical drawing. Before this one, I would like to just define some dimensions. I would like to have a loose fit at this position. As you see, I'm just going to just right click, dimension properties, change the limits and size, limits and fits. I would like to have a bigger dimension with F8, F7 or F8. It will be enough for us. And we just create that dimension relationship, and we will just get that dimension in the technical drawing which we have created. First, the base view. I rotate the base here and just change the scale to 1:1. Create one view here. I will just extend the dimensions here. I will get the first, I create the axis line, get the dimensions. For outside diameter I'm not interested in too much, but inside it is much more important for us because we would like to have a loose fit. Also, we can just use the relationship which we have seen on the tables, given on the tables. You can give, I only imply this one, start a new sketch and add a border line for our part view. Let's use this one. Finish the sketch. I'm sorry, I take my move back, get this one. I will move a little bit, copy and paste. This is the 13th part, which is it was handle bush, which is this one. I'm going to also change the type of handle pin, which is this one. Okay, this is all for our parts. I will just save all 2 parts. Also, I would like to show you which the mistakes that I made in spring part. Let's review about unknown. I have 2 missing things to show you. Let's open this part. Okay, anyway, I can open from here. I need a spring here. As you see, in the first part we have just created this sweep, and after this sweep we have created a work plane which passes at the midpoint of our figure here by using this sweep profile. Also, I create a mirror plane which I'm going to use on the other side. For the first sweep, I just make some sketch changes. I will just get this, create first of all a sketch on this surface. Then I create a path, not this one. I create a path with the dimensions shown in our part. This is our part dimensions, which is, it will just have 0.025. It is the center of this pathway. I have made a mistake at that point. If I give the dimension 0.024 here, I will use that dimension and I will just continue about this figure. This is the first mistake that I made. Also, I made another, I'm sorry, finish my sketch. And this one I'm interested in. I will delete. The next thing, what I did is, I have made a pathway here and make this tangent a line passing from this point, also tangent to this circle. This circle has no dimension. I made that mistake. If you need a dimension, I can just tell that dimension it is 0.021 inch radius here for your information. I will just close this visibilities. The next thing what I did is I need to take the mirror body on the other side and take another mirror. This time I will just delete the other side. I will take the mirror of this hook side, which is this one. It will be like this. I will change the other side. And during this mirror, I have just used the option which remove the option, and I use the mirror of solids. Please just keep in mind, first let me take this back. First of all, I would like to have a mirror of these two solids. Have the mirror command. Again, I'm repeating because maybe on our spring side. This time I use the mirror solids. Choose this solid and this solid and choose the mirror plane, which is just sits on this plane. I will first create the mirror of it, then I will just create another mirror. Again, the solids, this one and this one to other side, and I will remove the original one. Okay, I will just again mirror this one and this one for other solids. I will use the original one. Okay, this is the changes that I made from our side. And also I will just make another change. I will just recalculate the dimensions between these two ends before making the coils of our figure. Here we have 0.102 inches between the parts of these part ends. We have the sweep ends between these, and we will adjust a coil here. We have this profile, and I will just adjust that profile with 3 revolutions. We have 3 revolves around, and I will just adjust that revolve with this formula. We have a length here which is 0.102, and I will have 3 revolutions. I will divide that revolution dimension into 3. For this I need meet the ends of these parts, and I will just combine all the parts after this one. Before this combine command, we have 4 solids. As you see, we have 4 solids on the top side. After this one, we have 1 solid reduced to this one. Okay, that's all for our parts. We are going to make the other parts, and also we are going to just bring the dimensions and also the other components in the assembly modeling side. Okay.